Hi and welcome to a new 3DE4 tutorial. In this video, we learn how to use 3DE4's automatic tracking engine for tracking thousands of tracking points in a very short time. First, a basic workflow is shown from configuration possibilities to detecting badly tracked points. In Chapter 2, we create and edit spline masks to force the auto-tracking engine to track points only in specific areas. Alright, let's waste no time and get to work. Of course, we need a shot. All footage needed for this course can be downloaded from section Download at 3DEqualizer4.com. This big archive contains a folder with all sequences being used in 3DE4 basic tutorials. Okay, in 3DE4, select button, Browse. In folder Tutorials 4, we can find shot Trackboy Slim. Import this sequence. Let's compress and cache all images by exporting them to a so-called image buffer compression file. This feature saves the compressed shot into a single file within the same folder as the footage and within the memory. Perfect. Let's examine the shot. We see handsome trackboy playing with a blue box while the camera slightly moves around him. Enough introduction, it's tracking time. Switch to Auto Tracking controls. And add Timeline Editor to the main window. The buttons and display area changed. But at first, we'll have a look at Auto Tracking settings in Attribute Editor. Here we find all options needed to control the tracking engine and point density. Be excited! Right after explaining all parameters, we'll go to demo these settings. 3DE4's auto-tracking procedure can be divided into 3 steps. Step A, 3DE4 searches for suitable features in the shot and creates a new 2D tracking point for each feature found. In Step B, each point created in the step is tracked frame by frame as long as possible. During this period, a point is labeled as active. If a point cannot be tracked any longer, for example, it's simply not visible anymore, the engine decides to stop tracking this point and sets it to inactive. The ending of a track is Step C. To make it short, Step A is searching for points, Step B tracking them, and Step C is ending a point's tracking lifetime. Okay, now we know basic auto-tracking theory. What about the settings we find in Attribute Editor? Active points per frame sets the approximate range of points per frame. With the default setting, 3DE4 tries to find enough features that 30 to 60 active points are available in every frame, including already existing points. In case there is a frame with less than 30 points, 3DE4 will perform Step A, searching for features trying to fill up the set of active points. Minimum track length sets the threshold for deleting inactive points. Here, if a point could be tracked less than 10 frames, the engine happily says farewell and deletes it. Parameter search interval sets the interval for performing Step A. With this value, 3DE4 is forced to search new features every 15 frames, regardless from the current number of active points. Both size and minimum distance parameter define, as you might guess, the size of each point's tracking area, search area and pattern, and how close tracking points can be created to each other. Tracking sensitivity allows us to define how soon a feature is declared to be gone. A value of 1 sets a very high standard, resulting in an excellent quality but rather short tracking frame ranges. A value of 0 results in points with relatively low quality but longer tracking frame ranges. As always, setting the correct value highly depends on the footage. For most cases, the default setting of 0.75 is fantastic. Last, compensate luminance changes enhances a correction for exposure changes. In cases with heavy changes, this option will help, but at the cost of performance. Well, so much theory. But now comes the fun part. Let all parameters set to default values and click on button Auto. In the upcoming requester, we see 2 option menus for 2 parameters, the primary and secondary pass. This is explained quite fast. The primary pass is what we learned just a minute ago, steps A to C. Suitable features will be searched, points created, and ended if they cannot be tracked any longer. By default, the tracking direction is forward. It starts with frame 1 and ends in the last frame of the sequence. During the secondary pass, after reaching the last frame, 3DE4 tracks the existing auto-tracking points in the opposite direction for the possibility of extending their frame ranges. No additional points are created here, so basically it is just step B and C. Of course, the tracking direction can be set freely to forward or backward, but the secondary pass can only be tracked in the opposite direction. Obviously, tracking the same way twice won't make any sense. Both passes can be skipped as well. Of course, just one at the same time. Quickly reset both parameters to default setting. The last option here is track within frame range only. It is currently grayed out since no frame range was set in frame slider. Let's close this window and move both light gray handles at beginning and end to a random frame. Good, we set a frame range. After clicking again on auto, we see the toggle button is clickable. Now, the auto-tracking engine would track points only inside of set range. If we do not activate this option, any frame range setting will be ignored. But to prevent any confusion, let's move both handles to beginning and end of the shot. Then return to requester, perform auto-tracking. Okay, no more parameters left. Finally, let's start the auto-tracking by selecting button Track. The tracking procedure begins right away. Several red points appear on the footage, which are tracked frame by frame. After a while, some points turn yellow, indicating these points have reached the minimum track length. As set in search interval, every 15 frames new red points appear. This procedure repeats until the end of the shot. Alright, the primary pass is complete. As we can see, a step-like shape was formed during tracking. This happened since 3DE4 was forced to create new tracking points every 15 frames. Such a distribution of points might lead to problematic bumps in the reconstructed camera path, since the solver suddenly gets a lot of new tracking information in a single frame. To distribute the start frames of these points more evenly across the entire shot, secondary pass will take over from here. All points actively tracked in the secondary pass are displayed in purple. And here we go, the step-like structure disappears. 3DE4 is able to track most of the points much longer in backward direction. Let's have a quick look at the shot. Across the entire shot, points were placed. Further, the point group in Object Browser indicates that 70 points were created automatically. This might be enough to solve this shot, but we are here to demo the capabilities of auto-tracking, so there's room for more, much more points. Start clean and delete all of them. Deleting points can be done via 3 methods. With all points selected, using menu item delete here in the context menu, menu item delete in menu edit, or simply by pressing key delete on your keyboard. Timeline editor can be closed. We just learned about the effects of secondary pass. So, the next goal is not reaching 80 or 200 points, but over 1,000 ones. Having a blank point group, set parameter active points per frame to 1,000 and 1,500. Hit button auto, then track. We see the amount of points was increased instantly. Definitely not bad, but quite far away from the targeted 1,500 points. Well, over time we get closer and closer to 1,500, but the distribution here is not ideal. To be honest, it's very bad. We better stop the tracking. All points are placed evenly across the image. They seem to have the same distances towards each other. There is no variation. Further, the average track length of a point seems to be quite short. Obviously, the auto-tracker chose features for tracking that don't suit quite well. Reducing the value of tracking sensitivity might help with at least the track length, but we like to maintain tracking quality, and looking at the sequence and points, we see the features here aren't that hard to track. And after all, that won't solve the limited point amount and the unideal distribution. The bigger issues with this track result. So, The problem is somewhere else. The auto-tracking engine simply reached its limit. With a set minimum distance of 32 pixels between each point, this is the only option to place so many points within the borders of the image. So, to increase the number of points and place them more variable, we have to make more room within the image. We need to reduce their distance. Set parameter minimum distance to 1%. Then delete all existing tracking points. Good. Again, start the auto-tracking procedure. Nice. This looks much better. 3DE4 instantly could create the targeted amount of active points and, more importantly, their distribution is much more variable than before. Great. Approximately 2,300 points in the end, just by reducing the minimum distance. Have a look at the sequence. For a better overview, let's hide the footage with its quite disturbing background. Deactivate View, show images while dragging. Then scrub through the shot. Much better. We can precisely see all points and distinguish trackboy from background. Undoubted, we do have enough tracking points. So let's calc the project. Well, a deviation of 0.8 pixel is clearly not bad. However, there's room for improvement. When looking closer, we can already detect points with a quite bad tracking quality with our eyes alone. But checking each of the 2,300 points individually would indeed be annoying. But how else can we distinguish bad points from the good ones? One clue would be the individual point deviation. Activate Deviation Browser, show point deviation curves, all points. Oh yeah, they are really bad points we quickly should get rid of. So simply delete them. Stop. Wait. What if the tracking of some points is quite correct and other badly tracked points influence them? Simply deleting points purely based on their deviation is not wrong and would improve the reconstruction quality. But having so many points with such a huge deviation influencing the other points, might there be a better and more reliable way? Of course there is. 3DE4 provides a function for this job. Open Calc, find badly tracked points. Here we have some options to control the analyzing algorithm, like which points should be included and what should 3DE4 do with found points. Further, we can set the sensitivity. Like in auto-tracking settings, 1 is high and 0 is low. Overall point movement speed defines the threshold for the consideration of points moving slower in the footage, like points in the background. We leave everything unchanged and go straight to button OK. Good. Seems a handful points could be found. Alright. Quite a lot of points were selected. The complex algorithm behind find badly tracked points does not simply look for deviation values, but, to explain it very simplified, check the triangulation of each point towards each other. It's quite noticeable that most points are placed on or around trackboy. Not such a big surprise considering he and the box are the only ones actually moving in the shot. However, we have some really bad points we can happily delete. Calc all from scratch to get a new result based on the modified amount of points and therefore a modified tracking information. Nice. Deviation went down by 50% and peak deviation was reduced tremendously as well. There are still some points with high peaks definitely indicating tracking errors. Of course, we can run again find badly tracked points. But after the worst points were removed from the project, their influence on other points is gone as well. So to speed things up, as an additional cleanup, we can select the remaining points with high peaks. Again, we see all these points are also on or around trackboy. So quickly delete them. Then again, calc all. Great, deviation went down a bit further. This looks really good. We achieved this good solve by simply eliminating roughly 10% of all points. We can expect the remaining points are acceptable, so it's a good foundation for the last step of this chapter, adjusting the lens for further enhancement of reconstruction quality. We will do a very quick and rough adjustment. For a more detailed tutorial of lenses and distortion in general, please refer to tutorial Lens Distortion in section Tutorials at 3DEqualizer4.com. Let's add parameter adjustment window to the main window. Then add parameters focal length and distortion degree 2. Great. Set both to adjustment method adaptive. Then start the adjustment. This adjustment will take some time with so many tracking points needed to be considered. After a while, we're getting lens values resulting in a further greater deviation. Transfer parameters, then calc all again. That's how it should be. We further reduce the deviation by roughly 40% with these simple and quick methods. Finally, a quick look at the reconstructed scene in 3D space. Switch to 3D orientation controls. Looks really interesting. We clearly recognize the wall, and even Trackboy's shape and the ladder are identifiable. Quite a dense point cloud. As good as the reconstruction is, this point cloud shows us a problem with auto-tracking. Sometimes we just like to reconstruct parts of a shot. The auto-tracking engine, of course, cannot know by default which it should track and which not. In our case, we'd like to reconstruct the wall. Unfortunately, Trackboy is standing there, waving around his precious blue box. So, how can we teach the auto-tracking engine to exclude him from tracking? The answer is masks. In this chapter, we will learn how to create and modify spline masks to exclude all areas we don't like to be tracked. Let's go back to auto-tracking controls and quickly delete all existing 2D tracking points. Then have a look at auto-tracking masks. 3DE4 offers two different possibilities for working with masks: spline masks and image masks. In this course, we will focus on spline masks, which are enabled by default. But let's have a very quick look at the image masks. If they are available for your project, they can be imported in 3DE4. With button Browse. Image mask enabled will display it. Last, this mask can be inverted, so the dark area and therefore Trackboy is now excluded from the auto-tracking procedure. Well, that's easy, isn't it? But having such an image mask is quite uncommon, so, as always, a match mover has to help himself with spline masks. So, create a new one with button Add Mask. A mask formed by 3 red-colored CVs appears. As you might guess, the area within this mask won't be considered during the auto-tracking procedure. Of course, this mask can be inverted as well to define a specific area enabled for tracking. But in our case, we'd like to exclude box and Trackboy to track wall and floor alone, so deactivate the toggle button. So good so far. Now, how can the mask be modified? It surely won't stay shaped like this. To select a CV, simply click on it. A selected CV is displayed in a yellow color. To select multiple CVs, either click on them while holding down key Shift or using the selection tool. Both rectangle box and lasso selection can be used. Using selection tool and key Shift inverts the selection status of every CV inside the selection. So selected CVs become unselected and unselected, well, selected. If we like to translate a selected CV, simply click drag it to the desired position. To translate multiple selected CVs, hold down key Shift while dragging them around. Great! The next modification possibility we'd like to know is changing a CV's interpolation. Simply click drag one of its green handles to change the interpolation between two CVs. An auto-tracking mask is created with spline CVs by default. To change the interpolation type, select Edit, Toggle CV Linear Spline. Alright, creating a new CV is identical to creating a 2D tracking point. Hold down key Ctrl, then click anywhere in display area. The new vertex is automatically inserted between the nearest two CVs. The last thing to know is how to delete a point. Simply select a CV, then click button Delete CVs. As always, multiple CVs can be deleted as well. Finally, to delete the entire mask, simply select at least one CV of the soon-to-be-gone mask. Then hit button Delete Masks. Alternatively, a mask can be selected in Object Browser. Expand the camera list item. Here, we see all masks associated to the camera. Select the mask, then again button Delete Masks. So, we know everything about creating and modifying a spline mask. Let's use this newly acquired knowledge to create a nice mask covering Trackboy. Everything except his right arm. We'll get to it later. At first, we need a new mask. Good. Then place the 3 CVs that it roughly covers him from top to bottom. Next, create new CVs and position them more accurately around him. Also with the help of the handles. Perfect. With just a few clicks we masked him out. Well, it's perfect for this frame. Unfortunately, we have a shot with a moving camera, so Trackboy won't stay at this position the entire sequence. Scrubbing through the sequence, we see the mask is moving away from him pretty quickly. But we also see the camera in this shot is just moving horizontally along the set. So animating the mask that it covers him in every frame won't be effortful. Maybe just 3 keyframes at beginning, middle and end will do the trick. When modifying one or more CVs, a keyframe is created automatically for this specific frame. A mask's keyframe is displayed in Frame Slider by a red colored frame. So, keyframe 1 is already complete. Go to a different frame in the middle of the sequence and select all CVs with button Select all CVs. Then move the entire mask so it again entirely covers the young gentleman. Repeat this for the last frame. Great. Check the mask throughout the entire sequence. Perfect. Trackboy is now excluded from the auto-tracking procedure in every frame. As mentioned, we deal with the arm later. So, what about the box? As previously, create a new mask. A quick tip. Masks can be created in an object browser as well, by right-clicking on Entry Camera or Mask. Then select Add New, Auto-Tracking Spline Mask. But we don't need a third one, so let's work with the 2 existing. We know how, so let's adjust this one to the blue box. A linear interpolation might suit much better for the box shape. Nice. Our box is covered completely, so the next step is animating its mask. When having a look at the sequence, we see the box motion is a bit more complex than Trackboy's due to its rotation. Let's adjust the mask and therefore set a keyframe approximately every 20th frame. Okay, check the shot. There still are some frames with an uncovered box. Let's quickly fix this. Good. By the way, the keyframes displayed in Frame Slider always belong to the currently selected mask. However, both masks, selected or not, are equally active in display area, so we can select and modify CVs of both masks at the same time. This is quite handy for the feature we'll use next. As we can see, the arm is still uncovered, So instead of lavishly expanding one of the existing masks, we will simply join them, forming a single one covering everything in between. Joining masks is very easy. Select 2 CVs of each one. It doesn't matter which one, 3DE4 figures it out where to join them. Then click button Join Masks. Amazing! Both masks were merged into a single one, as also listed in Object Browser. To split masks again, select those CVs which should belong to the separated mask. Then click Split Masks. Of course we need a single mask, so join both again. Check the new shape throughout the entire shot. Oh, here the hand peeks out a bit, so correct it. Well, everything fine now. The last step in this tutorial is again tracking some points with the Autotracking engine to see if the masks are working. Should I spoiler here? Nah, look for yourself. Expand Autotracking settings and leave all parameters as they are. Everything's prepared, so select button Auto. Then hit Track. After a while, the auto-tracking procedure has finished. Let's check if no points were tracked within the spline mask. Scrub through the sequence. And here we go. We clearly see not a single point inside the mask. Mission accomplished. As a bonus, let's calc all and check the reconstructed point cloud if TrackBoy is also gone in 3D space. As previously, remove all badly tracked points from the project. Then calc all again. A single removal is sufficient for this demo, so we can go directly to 3D orientation. Great! We see the wall alone, no TrackBoy visible anymore. Really nice. In this tutorial, we learned about the auto-tracking feature in 3DE4. We got a sense about the 3 steps during an auto-tracking procedure, its settings and how to modify them for increasing the amount of tracking points and a more variable distribution. Further, spline masks were introduced to exclude areas from being tracked. During this chapter, we saw how to create, modify, join and split masks. That's it. Thank you very much for watching. I hope you enjoyed this tutorial.